Welcome friends, I am Tanmay. So today we are going to discuss a question came in the CSIR-NET exam June 2011. This problem is about aromaticity. So the question is, you can see the compound 1, 2 and 3, A, B and C. The question is, what is the correct order of acidity? And 4 options are given. This is a 4 marks question. Okay, we will discuss today what is the correct order of acidity. Okay, let's start. So, since the question asks that what is the correct order of acidity, acidity means we have to check the stability of conjugate base. For example, if we consider HA, then we have this is H plus A minus. So, acidity means we have to consider the stability of this conjugate base. Okay. So let's consider about the conjugate base. Means what will be the conjugate base? And another thing, first when you have to check from where the proton will go. Since acidity means proton will go, and we'll discuss the stability of conjugate. So you have to think about this. First proton abstraction will happen from here, here and here. So other options are there, but that's not possible, energetically unfavorable. That's why we will check this. So, if it loses proton, the structure will be (5CF3) with a minus charge. Similarly, if it loses proton, what will be the thing? Minus. If it loses proton, it is similar like the previous one, but actually all 5 are methyl. So now you have to think that okay, these are the thing, and everything is conjugated. For example, this can delocalize its lone pair. This. Let's draw at least one resonance structure. Means this here, this is here. So the resonance structure is this. Minus charge is here. So in this way, other resonance form possible. So I am not going to write that. This is one resonance structure, which is this will come here. And resonance negative charge will come here, and for this now this will come here, similar like the previous one. So ultimate the delocalization pattern will be this and this, and so on. In every case, resonance will go on. So from this you can see that resonance will happen. Okay, so this will describe the stability. First example, from all you can see all is conjugated, all are conjugated material. So this question come from aromaticity. You have to keep this fact in mind. So if this problem comes from aromaticity, so then the most important thing is Huckel rule. Huckel rule means all the conjugated part contain a p orbital. All the atoms involving aromaticity should contain a p orbital. Second, it should be planar and cyclic. And third is 4n plus 2 number of pi electron. Okay. So this is the most. For example, everything is planar, every molecule. It is conjugated also. So first point, second point covered. Now let's come to the third point, 4n plus 2 number of pi electron. Now let's count how many pi electrons are here. For example, this contain this 2 and 1 pair 6 pi electron. This contains 2 and 2, 4 pi electron. Okay, this contains also 6 pi electron. Okay, fine. Now we have to consider which one is aromatic, which one is anti-aromatic, because everything is conjugated. So non-aromatic not possible. Aromatic versus and so 4n plus 2. If n equal to 0, then the value is 2. If n equal to 1, the number of pi electron is 6. For example, this is 6 electron, this is 6 electron. Okay, this is 4. Let's check whether anti-aromatic. Anti-aromatic is 4n number of pi electron. Okay, then if n equal to 1, then 4. If n equal to 1, the number of electron is 4. Okay, 4 electron. So this indicate that this is anti-aromatic. Anti-aromatic. Okay. Now this is aromatic. Okay, this is also aromatic. Now according to the nature of aromaticity, actually aromaticity is stabilization. Aromaticity means delocalization, which brings stabilization. So this is anti-aromatic, so unstable. So let's eliminate this option. Okay, so let's eliminate this option, that okay, this will be least stable. The conjugate base, this will be least stable. So this will be least acidic, means reluctant to give proton. Okay, okay. So right now, if we see this will be least, then check the condition where it is least. It is B. B is least here. Okay. Actually, you are lucky that from here you can say the answer will be this. It's true. No need to think more. And for in exam hall, you should apply such type of tricks. No need to invest more time, even few seconds, for check further thing, because B is least stable. So this is the answer. Okay. Okay. But due to learning purpose, I will explain both also, because this question is not going to come again. Some new question will come, so it is essential to understand the basic concepts. That's why if you consider these verses, now the question is, this is also aromatic, this is also aromatic. So which one is more stable? Actually, let's eliminate this part. So this is aromatic, but this aromaticity is due to the charge. Okay, and charge means unstable. Actually, these both are carbanion. So carbanions are reactive species. Now, if the electron density on the carbon is delocalized more and more, dispersed over different atoms, then it will be more stable. Okay. Now, if we check the difference between these verses and this, so what is the difference? Actually, difference is this methyl group versus CH3 group. This is the main difference. Nature, methyl is donating plus I and CH3 is withdrawing minus I. So, for carbanion stability, minus I is more important because it's withdraw electron density. So, it helps to delocalize or disperse the charge through sigma bond. Minus I operates through sigma bond. Okay? Okay. Now you can see negative charge, here CF3, here 5 CF3, here 5 methyl. So these are plus I effect, this is minus I, so it will stabilize this charge due to this withdrawing nature of this CF3 5. So this will be most stable among 3, and this is second. Okay, okay. Now let's verify the answer again. First, maximum stable will be A. I have explained why most stable. Second is C, and B. So this is the answer. But now for exam hall, will you spend this much time? Not recommended. You should not you should not draw all this thing to spend more time. First, how you try to solve this problem in exam hall. First, check. Okay. They are asking what is the acidity, means proton will go. Okay, fine, proton will go. Now the question anion will be our negative charge. You have to think everything in mind, or you can draw only one structure, that okay, this is CF3, this is CF3, this is CF3, So this is negative, and similarly this is also negative. Okay, now which one is more stable? Withdrawing group. So this is maximum stable, this is this, and least is this. So first clever technique is the which one is least stable. For example, in some another case, they give another option. If they give, for example, B greater than A greater than C, some clever strategy. So here right now you have two options, which is this is unstable. So right now you have to think which one is more stable, A or C. So from this point you can see this is more stable, so correct choice is this. So this MCQ pattern could be changed, but you need to be careful and smart enough. Don't waste time. For learning it is good to draw everything, but for exam purpose every second is important. So I guess in this way you can solve the question very fast, even a 4 marks question with very less amount of time. Okay, so this is the end of this video. Next video I will explain another question. So if you like my videos, please give a like and subscribe my channel Chemistry the Mystery of Molecule, and share this video with your friends. So thank you everyone. Let's see you in the next video.